Kilonova, kilonova, kilonova. What is kilonova? A kilonova is a cosmic event that occurs when a neutron star smashes into another neutron star or a black hole. It releases heavy metals like gold, silver, and selenium into outer space at tremendous velocities, as well as radiation. A kilonova radiation also accompanies a gamma-ray burst, one of the most energetic cosmic events ever known. What is a neutron star? Neutron stars are formed when a massive star runs out of fuel and collapses. The very central region of the star, the core, collapses, crushing together every proton and electron into a neutron. If the core of the collapsing star is between about 1 and 3 solar masses, these newly created neutrons can stop the collapse, leaving behind a neutron star. Many neutron stars are likely undetectable because they simply do not emit enough radiation. Kilonova, a powerful event that happens when two neutron stars merge. As described in our press release, NASA's Chandra X-ray Observatory has been collecting data on the kilonova associated with GW 170817 since shortly after it was first detected in gravitational waves by the Laser Interferometry Gravitational Wave Observatory, LIGO, and Virgo on August 17, 2017. GW 170817 was the first, and thus far the only, cosmic event where both gravitational waves and electromagnetic radiation, or light, were detected. This combination provides scientists with critical information about the physics of neutron star mergers and related phenomena, using observations at many different parts of the electromagnetic spectrum. Chandra is the only observatory still able to detect light from this extraordinary cosmic collision more than 4 years after the original event. Astronomers think that after neutron stars merge, the debris generates visible and infrared light from the decay of radioactive elements like platinum and gold formed in the debris from the merger. This burst of light is called a kilonova. Indeed, visible light and infrared emission were detected from GW 170817 several hours after the gravitational waves. Initially, the neutron star merger likely produced a jet of high-energy particles that was not pointed directly at Earth, explaining an initial lack of X-rays seen by Chandra. The jet then slowed down and widened upon impact with surrounding gas and dust. These changes caused an increase in X-rays observed by Chandra, followed by a decline in early 2018. However, since the end of 2020, the X-rays detected by Chandra have remained at a nearly constant level. The Chandra image from data taken in December 2020 and January 2021 shows X-ray emission from GW 170817 and from the center of its host galaxy, NGC 4993. A research team studying the Chandra data think this steadying of the X-ray emission comes from a shock, like a sonic boom from an airplane, as the merger debris responsible for the kilonova strikes gas around GW 170817. Material heated by such a shock would glow steadily in X-rays, giving a kilonova afterglow, like Chandra has observed. The artist's illustration shows the merger debris responsible for the kilonova in blue surrounded by a shock depicted in orange and red. There is also an alternative explanation suggesting that the X-rays come from material falling towards a black hole that formed after the neutron stars merged. This material is depicted by a small disk in the center of the illustration. To avoid a coincidence, it is likely that only one of the two options, the kilonova afterglow or matter falling onto a black hole, is a significant source of the detected X-rays. The two blue glowing arcs of material above and below the kilonova show where material from the now faded jet has struck surrounding material. To distinguish between the two explanations, astronomers will keep monitoring GW 170817 in X-rays and radio waves. If it is a kilonova afterglow, the radio emission is expected to get brighter over time and be detected again in the next few months or years. If the explanation involves matter falling onto a newly formed black hole, then the X-ray output should stay steady or decline rapidly and no radio emission will be detected over time. Researchers recently announced a source was detected in new Chandra observations performed in December 2022. Analysis of that data is ongoing. No radio detection has yet been reported. NASA's Marshall Space Flight Center manages the Chandra program. The Smithsonian Astrophysical Observatory's Chandra X-ray Center controls science operations from Cambridge, Massachusetts, and flight operations from Burlington, Massachusetts. What is the news? Researchers have confirmed the detection of a star system that will one day end in a kilonova. Scientists believe that only 10 star systems that exist in the Milky Way will end in kilonova. The newfound one has been labeled as CPD 292176 and is located about 11,400 light-years from the Earth.